will discuss one of the most important component which are used in the electronic gadgets is the resonator. We use resonator in the electric circuit just to get the specific frequency. What is resonator? A resonator is an electronic component that oscillates at a specific frequency when excited. And resonator are commonly used to regulate oscillator frequencies in the clocks, communication system, and more for precise frequency regulation as well as in the stability purposes. Resonators offers more use in the signal processing. We use it in the filtering and the frequency generation application as compared to the crystal due to its wider frequency tolerance range, and it is more versatile uses in the signal processing, filtering, frequency generation as well as time precision. Whenever we require the frequency generation, whenever we require the filtering, signal processing, then we use such type of electronic component, that is a resonator. If we talk about the resonant circuit, it is an electrical circuit which is composed of discrete components that can act as a resonator. When we just take the inductor and the capacitor, then we just get the resonant circuit. Oscillations are limited by the inclusion of the resistance, either by a specific resistor component or due to the resistance of the inductor windings. So such components means RLC that just give the resonant circuit. So resonant circuit are also called the RLC circuit, another circuit symbol as it say, as we use the RLC as a component, that's why it is also called the RLC circuit. A distributed parameter resonator has capacitance, inductance and the resistance that cannot be oscillated into the separate lumps capacitors, inductors and the resistors. For example, much used in the filter and in the helical resonator. An inductor consisting of a coil of wire and is a self-resonant at a certain frequency, which is due to the parasitic capacitance between its turn. As we are having a turn, then we have the then we can find out the self resonant in it, and this often an unwanted effect that can cause the parasitic oscillations in the RF circuit. So the self resonance of inductors is used in the few circuits such as Tesla coil. Means we use a resonant circuit in the Tesla coil whenever we just find out the self resonance. Resonators are frequency selective electronic circuit that can produce a fixed frequency, means we can get the resonant frequency through this electronic circuit. So resonator are the frequency selective electronic circuit that can produce a fixed resonant frequency when properly excited. So the value of resonant frequency depends on the circuit's components, which components we are used, which parameters we are used. On the basis of that we can have the resonators. There are the several basic type of resonators we will discuss later, but here we discuss there are the several type of the basic resonators, that is the ceramic resonators which used which can be built by the piezoelectric ceramic materials and which have a suitable mechanical resonance property. It means it comes under the mechanical resonators, and it produces the vibrating frequency that is a function of the resonant frequency which we are applying. And there are another type of the resonator which is surface acoustic wave technology that has generated the elastic waves that propagates on the surface of a specific material. So the energy density of the waves is confined to a depth of no more than the one wavelength. And other type of, if we talk about the SAR devices, and they have the high frequency selectivity, they have a low insertion loss and can be manufactured in the small size chips or dies. So resonators with the quartz crystal or the passive electronic component are also available. So RC resonators include the resistors as well as a capacitors. LC resonator, that is having the inductors and the capacitor. So a resonator is a device or a system which is capable of oscillating with increased amplitude at a specific frequency, and that frequency is called the resonant frequency. And these frequencies are decided by the dimensions of the resonator and the characteristics of the components and type of the resonator which we are using. So resonant frequency is the specific frequency that just we get from the oscillation. So they are the wide used in the various electronic application, including the filter, oscillators and the frequency selective circuits. And the reason why they are used because they are capable of stabilizing frequency in the communication devices, clocks and in many systems. If we talk about the performance specification of the resonator, so performance specification for the resonator include the oscillation frequency. That is the main important parameter of this resonator is the oscillation frequency. Another, just we calculate the frequency tolerance, that is the performance parameters, total frequency, stability and the operating temperature. So whenever we just prepare a resonator, so these points keep in the mind for the preparation of the resonator for the certain applications. So oscillation frequency is a nominal frequency value. Frequency tolerance or the frequency error is allowed, stating deviation from the nominal oscillation frequency. So first is oscillation frequency, which is a nominal frequency. After that, if we talk about tolerance, tolerance means frequency error from the, typically frequency tolerance is expressed as a percentage. How we can calculate it? Total frequency stability is the maximum frequency and deviation from the nominal value for all the condition, including the supply voltage. So this amount is usually expressed in the part per million, that will be defined as ppm. That is a parts per million, that will define the frequency tolerance. Frequency tolerance means ppm. Operating temperature is the full required range of ambient operating temperature, because that temperature we require for that in which conditions we are using the resonator. So temperature is one of the parameters just for selecting the resonator. Resonators are devices or the system that amplifying sound or electromagnetic waves at a specific frequency. So they come in the various forms, like the mechanical, that will be the acoustic, electromagnetic, that will be the RF and microwaves, and the optical resonator. So we define the three types of resonator, in which first is a mechanical, that is acoustic, second is electromagnetic, that is electronics, and third is the optical resonators, that will be based on the optical parameters. Now some common types including the cavity resonator, that will be used in both the form of the resonator, coaxial resonators, dielectric resonator and the optical resonator. And the optical resonator we all know that we use in the laser system. So laser system, there is a variety of the optical resonator that are used in the optical system. So what are the types of the resonator? First, as we discussing, that is a mechanical acoustic resonator. Mechanical, that is also the acoustic resonator. So these type of resonator amplify the sound waves at a specific frequency, and these are often used in the musical instrument. For example, Holtzmann resonator in the fluids, we use it, or to enhance or damp specific frequency in the audio system. Means whenever we require the audio frequency, then we use this type of mechanical acoustic resonators that will give the resonant frequency. Another type is a Helmholtz resonator. It is a cavity with an opening used to amplify the sound at a specific frequency. Another type of resonator in this category is the quartz wave resonator. It is a tube closed at the one end and used to absorb the amplified sound at a specific frequency. So that is a quartz wave resonator. And half wave resonator similar to quartz wave resonator but open at both the ends. So that we will use in the fluids generation. You have seen it many. So whenever we require the acoustic through the fluid, then or in other musical form, then we use these type of resonator. Another type of resonator is the electromagnetic resonator. And these resonator, these are the you can say it's the electronic or electrical resonator, and these resonate the electromagnetic waves including the radio frequency and the microwave frequency. And there are many types of the electromagnetic resonator. First is the cavity resonator. It is a hollow structure that can find the electromagnetic waves, which is used in the various application like oscillators and the filters. Another type is the coaxial resonator. So what is this coaxial resonator? This is a cylindrical resonator with an inner and outer conductor, and used in the oscillators and the filters. Another type of the electromagnetic resonator is the dielectric resonator. This is also the most common used resonator, and use a dielectric material to confine the electromagnetic waves, and it is also used in the filters and oscillators. Another type of resonator is the surface acoustic wave, that is SAW resonator, which use the surface wave in the material to resonate the frequency. Another type of resonator is yttrium iron garnet, that is YIG resonator, which use the yttrium iron garnet material for the resonance purpose, and it's often used in the microwave circuit, so where the temperature is also keep maintained. Another type of the optical resonator is the optical resonator. So it resonate the light wave and often used in the laser and the optical devices. So in this category we have the Fabry-Perot resonator, which is used the two parallel mirrors to trap the light within the cavity. Basically it just used for the amplification of the signal. So we use the two parallel mirrors, and in which between that the light wave will communicate, then it will amplify the light wave. So this optical resonator used to resonate the light waves. Another type of optical resonator is the ring resonator, and utilize a ring shaped path for the light to circulate. And in this category we have the distributed feedback, that is a DFB resonator, which employs the periodic structures to provide the feedback in the semiconductor laser. Another type is a bulk optical resonator, which use the bulk optical components and the free space propagation of the light. So this type of resonator we will use in the laser system. Another type is a waveguide resonator. Use the optical waveguide, and that is an optical fiber to guide the light. So these are the various three types. Other type of notable resonators are crystal resonator, that is, as the name suggests, it uses the crystal, the quartz crystals, to resonate at a specific frequency used in the oscillators and the timing circuit. And in this category we also have the ceramic resonator, which use a piezoelectric ceramics for resonance, often used in the lower precision application. Then we have the micro electromechanical system resonator, that is a MEMS resonator. Nowadays we are using this type of resonator. as we are in the era of the 21st century and we are working on the flexible electronics. So in this flexible electronics, the MEMS resonators are used because it is easy to construct it on the flexible substrate, as well as we can print it easily on the substrate. So nowadays micro electromechanical system MEMS resonators are used as a things are the electronic circuit is going to be miniaturized, so we can print, we can draw these MEMS through the various methods on the electronic circuit. So it utilizes the tiny mechanical structure for the resonance and offering the low power and high frequency capabilities. So nowadays we use the MEMS. Another type is the bulk acoustic wave, that is BAW, that is that resonator is the mechanical wave within a material to resonate at the frequency and good compact size and having the shock vibration and resistance. So we have another type which is a conical resonator, and we have a generalized spherical resonator, cone resonator, and there are the parallel loop resonators, then saddle resonator, loop gap resonator, bird cage resonator, dotted resonator, plane parallel resonator, concentric spherical resonator, ring resonator, confocal resonator. So there are the various type of the resonator. Now in this lecture we will discuss the electromagnetic resonator, and it means we are having the electrical properties of that resonator, and we talk about the electronic resonator. So one by one we will just discuss the brief about these type of resonator, that is the electrical resonator or the electronic resonator. Before starting that, we discuss what are the electrical properties of the resonator that will be used for the detection. So explore the electrical specification like the quality factor and the impedance that define the capability and the efficiency of a resonator. So first is the quality factor, that is also represented by the Q factor. And this quality factor or the Q factor represent the efficiency of the resonator in storing energy. So it is defined as the square of the voltage across the resonator and divided by the power dissipated in the resonator per cycle of the oscillation. That will give the Q factor, that is a quality factor, and it defines the efficiency of the resonator. Means we define the square of the voltage across the resonator and divided by the power dissipated in the resonator per cycle of the oscillation. So high Q factor means a lesser energy dissipation and the higher efficiency of the resonator or the cavity. Means we require the higher Q factor just to get the good efficient laser system. And there are the two type of the quality factor, high Q resonator and another is a low Q resonator. In the high Q resonator found a high stability and the accurate frequency control devices such as the crystal oscillator in the clock. Another is the low Q resonator. It is used where a wider frequency band is needed, such as some kind of the filter. Another characteristics is the impedance characteristics. Impedance is the most important aspect and is matching of the impedance which helps in achieving the maximum power transfer between the resonator and the component present in a circuit. Then how the maximum power can be transferred from the resonator to the other component, that will be defined by the impedance characteristics. So consequently the impedance of a resonator is a function of the operating frequency and it should be conjugate matched to a source and the load impedance for the frequency. So impedance characteristics, on the basis of that, two type of parameter we can define and two type of the resonators we can define, like the series resonator which is having the low value of the impedance at the resonance, and another type is the parallel resonator which offers a high impedance at the resonance. So in this impedance matching we are having the two types, series and the parallel. So resonator operates based on the principle of the vibration. What is the principle behind the resonator? It based upon the principle of vibration, as we get the frequency through this vibration. And when an external signal is applied to a resonator at its natural resonant frequency, the resonator starts vibrating and amplifying the signal. And this amplification helps to maintain a stable frequency by compensating or any losses and fluctuation that may occur. Means by avoiding all the losses, above all the fluctuation, a amplified frequency will be provided to the system. That will be the output to the another component. So resonator is the primary function of a resonator is to stabilize and control the frequency of an electronic circuit, and that frequency will be used for the further application. By providing accurate and precise frequency regulation, resonators enables the reliable operation of electronic devices across the various industries or the various gadgets. So, understanding the basic principle and the type of the resonator is essential in choosing the right component for the specific applications, ensuring optimal performance and the efficiency. So, now the next topic we will discuss, how does a resonator work. As we discussed, that is based upon the principle of the vibration. So, how these vibrations are used to generation of the frequency. So, a resonator works by the harnessing the principle of resonance to generate and amplifying the specific frequency in the electronic circuits. So, resonance occurs when the natural frequency of a system matches the frequency of then applied frequency. This result in the phenomena called the resonance. So, resonance, when we just apply the natural frequency to the system and the output is also the same, that will be provide the result of phenomena are called the resonance, where the amplitude of the system's vibrations increases significantly. So, the basic operation of the resonator involves the two main components. The one is the oscillating element and second is the feedback loop. So, the oscillating element, which can be made of the various materials such as the piezoelectric crystal, quartz or the ceramic, and is designed to vibrate at a specific frequency when stimulated by an external force or an electrical signal, and that will vibrate and that will generate the frequency. When an electrical signal of the resonator's resonant frequency is applied to the oscillating element, it begins to vibrate and generate the mechanical vibration. And these vibrations are then converted back into an electrical signal by the piezoelectric properties of the material. We are talking about one of the example of that. And this feedback loop allows the resonator to sustain its vibration and maintain a stable frequency output. So, the resonance phenomena occurs when the frequency of the applied signal matches the natural resonant frequency of the oscillating element. So, at this point the energy transfer between the electrical and the mechanical vibration reaches its maximum efficiency by resulting in a significant increase in the output signal's amplitude. In this manner, we can get the maximum efficiency through a resonator. The resonator's ability to generate and amplifying the specific frequency and make it an essential component in the various electronic devices and the system. For example, in an oscillator circuit, the resonator acts as the frequency determining element ensuring a stable and precise output signal. In the filter, resonators are used to selectively pass or reject the certain frequencies, allowing for the signal separation and the noise suppression. So, we use this for the in the oscillating circuit, and moreover we use in the filters that will pass or reject the certain frequency. So, these are the major role of the overall. The working principle of the resonator is based on the concept of resonance and ability to control the ability to convert the electrical signal into the mechanical vibration and the vice versa. So, through careful design and selection of the material, resonators enable precise frequency control and stability in the wide range of the electronic application. So, further we will discuss about the resonator in the next lecture. Thank you very much.